All right, let's start at the very beginning. Let's start with what we mean in a very basic way when we talk about probability. Probability is a way to express a ratio of the number of favorable outcomes to the number of total outcomes. It's a way to express the ratio of the number of things we want or the number of things we are interested in as it compares to the number of total possibilities that exist. So if we were to write the letters in the word mathematics, and we were to ask what is the probability of choosing a vowel from the set of letters in mathematics, assuming we're choosing at random, every letter has an equal chance of being chosen. How do we find that probability? Probability is a fraction. The denominator of that fraction is the number of total possible outcomes. This is the number of possible outcomes. Well, we're not going to pick we're not going to pick an Isuzu. We're going to pick a letter from mathematics. We're not going to pick a chicken. We're going to pick from the letters in mathematics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 11 letters in the word mathematics. So up here, we put the number of favorable outcomes. And the number of favorable outcomes are the number of vowels in mathematics. 1, 2, 3, 4, 4 over 11. The probability is 4 over 11. Because of this setup, probabilities are always less than or equal to 1, because it is never possible to have more favorable outcomes than possible outcomes. The most that can happen is that every possible outcome is favorable, and in that case you get 1. Also, probabilities are always greater than or equal to 0. 0 is the least possible probability, and that happens if there are no favorable outcomes. Probabilities are always fractions between 0 and 1. 0 is a possibility if the event has no favorable outcomes. 1 is a possibility if every possible outcome is favorable. So we have a die. It's a 6-sided die. We've got a 1 here, we've got a 2 here, we've got a 3 here, and then a 4 down bottom, a 5 on the side, a 6 in the back. We want the probability of rolling an odd number on the die. So we consider how many numbers there are on a die and how many of those are odd. 1, 3, and 5 are odd. 1, 3, and 5 are odd. That fraction happens to reduce. And this is what people mean when they unofficially say it's a 50-50 shot. What does 50-50 mean? Well, it means that there's a 50% chance that you roll odd and a 50% chance that you do not roll odd. Now, mind you, probabilities are fractions between 0 and 1. Probabilities are not percents, generally speaking. But sometimes people talk about it colloquially as if it were. And if you happen to do that with young people, I won't hold that too far against you. But generally speaking, when mathematicians speak about probabilities, they are fractions between 0 and 1. So let's talk about the other thing. You've got a dartboard, and the dartboard is on a wall. Now, the dartboard is 1 foot in radius, and it's on a wall in some establishment, and that wall is maybe, this is so not to scale, 10 feet tall. Now, let's go a little bit more realistic, right? Nobody's doing 10 feet tall. 8 feet tall and maybe 3 feet wide. We're going to throw a dart. What's the probability that it hits the dartboard? So we want the probability that we hit the dartboard. And that's going to be a fraction. Well, how are we going to figure out that fraction? We can't exactly talk about favorable outcomes and possible outcomes because literally every point in the whole rectangle, literally all of the, well, not that one, that's outside, but literally all of the points are possible outcomes. So that's, oh, really? I have to undo it all one at a time? That's silly. So that's not a good way to think about probability in this case. So instead, we think about the desired area as it compares with the total area. The area of the wall is 24 square feet, right? 3 times 8. But the area of the dartboard is pi times 1 squared. And so there is a pi over 24 probability that a randomly thrown dart hits the dartboard. Now, nobody throws darts at random. Although sometimes you may feel like you're doing it at random, you actually aim and you try to throw it at the circle. But if it were random, if you were just grabbing a dart and flinging it blind, there would be a pi over 24 probability that you would hit the dartboard. So about how big is that? Well, pi is a little bigger than 3, so this is a little bit bigger than 3 over 24, and that's a little bit bigger than 1/8. So figure 13%-ish. If you're thinking in terms of percents, it's a fraction that would convert to a percent as about 13%. It's not a very good chance. And that means that this picture is very not to scale. Okay, we could do the same. Oh, no, we don't do that yet. So we could do the same thing where we have some shape. Maybe there's a circle, and maybe that circle has a radius of 2 inches, and there's this square hole, and this is a square hole, and this is a square hole, and this is a square hole, and each of these are 1/2 inch on a square, and we want to figure out the probability of landing inside one of the squares. Well, the probability of landing inside one of the squares, well, that's a ratio of the areas of all the squares divided by the area of the circle. Well, the area of the circle is pi times radius squared. That's not a surprise. So then the area of each of these squares, well, each of these squares is 1/2 times 1/2 inch, and there are 4 of them. So that's 1 out of 4 pi. About how big is that? It's about 1 in 12, a little bit less than 1 in 12. So again, not very good odds, not a very high probability. But this is how we think about probability in a geometric context, because we can't figure out the total number of possible outcomes because there are infinitely many points inside the circle. And in fact, there are infinitely many points inside those squares. So hopefully this gives us some sort of understanding. There's another video coming that's all about a couple of special cases, but it's not very long. So you're almost done.